Welcome, dear learners, to the Introduction to Forensics and Ethical Hacking. In this course, I will expose you to the foundation of forensics, and then we'll perform ethical hacking before we go into the forensics part of the course. My name is Dr. John Effiong, and I'll be your facilitator throughout the course. These are the learning objectives. At the end of the lesson, we expect you to understand attack surfaces and then perform reconnaissance. In reconnaissance, you're going to learn passive reconnaissance and also active reconnaissance, where you engage with the target or the suspect. And then also perform initial exploitation, of course, learn the techniques and then perform that. And then finally collect evidence and then map the evidence to the analysis and then come up with the report. So for the learning of the lab overview, you'll be expected to simulate a case study which we call the Secure Bank Cyber Fortress. And then in this case study, you are going to bridge between red teaming. We're going to have to carry out ethical hacking, and then digital forensics. We are going to carry out forensic investigation and then perform compliance. So there are three major learning steps we have to follow. So the first phase is the attacking phase. Sorry for that. Let me get the pen. Yeah, the first phase is the attacking phase, where you will have to simulate the adversary's actions. So the goal is to discover weaknesses and also exploit those weaknesses, or what we call vulnerabilities. And then in phase 2, which is the investigation phase, you're going to apply your forensic science skills and tools or commands to establish what happened, how it happened, what was impacted, and also who carried out what actions. And these are the four key things that forensic science helps to establish: what happened, how it happened, what was impacted, and who performed what actions. And then the third phase, which is the governance phase, is where you have to translate technical findings. I mean, what you have discovered in phase 2 in your examination, translate that them into business risk and also compliance language. And then at the end of the day, finally, you are going to come up with what we call the professional incident response and handling reports. These reports will be consumed by IT staff and also your executive management. So it means that in your reporting or your report document, I'm going to have appendix for IT staff and also have executive summary for the management to consume. So for this, the case study we are looking at, which I've said earlier, which is Secure Bank Cyber Fortress, and we have to bridge between red teaming, forensics, and compliance. So here is the case. You are a senior security consultant at Cyber Shield Advisory. You were engaged by a secure bank after a suspected incident. Anomalous outbound traffic was detected from their online banking test server, that's the SEC bank test internal. Your job is to perform a controlled red team assessment to identify attack paths, conduct forensic analysis to determine breach scope, and then evaluate controls against regulatory expectations. Typically, you are to simulate the PCI DSS. The PCI DSS is the regulatory standard for payment cards. So that is what you are going to simulate throughout the course. So let's look at the lab environment setup. Now, we are working within the Docker environment. So the Docker is that platform, that infrastructure allows you to create containers, and then you can actually run the applications in containers. So we have 6 containers. We have the Secure Bank app, which runs on port 5000, with the host that's available Flask application, which runs on port 88. Then we have the attacker machine, which is Kali, Yes, with Kali tools, we can run Kali commands. That's where we're going to launch that task from. We have the Elasticsearch machine, which runs on port 9200. So, and then we also have the Logstash. That's number 4 container, which runs on port 5000. The host also on port 5000. We have the Kibani, that's number 5, which runs on port 5001, and the host on the same port number. And then finally, we have the secure bank database management system, the MySQL, which runs on the first port of 3306. So these are the containers that we're going to be working with throughout the course. So looking at the components of the course, or the components of the lab rather, so we have the variable app, and then the major script you're going to be exploring is the app.py. Now, this script has been intentionally made to be vulnerable, so one can exploit while learning through the course. And then for the Kali tools, which is the second component of the lab, the major script we're going to be working with, it's found in the scripts directory. We're going to see that shortly. And then we have the Elasticstack, which helps us to do local aggregation and visualization. That is number 3 components. And the last component is the MySQL database management system, which is going to show us the user accounts and the account data that we have there. So for the network topology, the secure bank network is the bridge network. We're going to see that. And then so we have the variable app. All of the machines run from class B IP address of 172 and then other octet to follow. So we have the Kali tools, we have the Elasticstack, and then we have MySQL. And then for access points and ports, web application runs on ports 8080. Kibani dashboard runs on port 5601. Elasticsearch API runs on port 9200, and then the Logstash TCP/DTP runs on port 5000. So the first phase of our experiment is to perform reconnaissance. Like I said, reconnaissance has two aspects. We have the passive, where you carry out the reconnaissance on the target or the suspect without the suspect or the target knowing that you are doing that. Just like you're gathering information from a website or from social media about the targets. Then we have the active reconnaissance, where the targets or the suspect gets to know that you are actually gathering information about the individual or the organization. Now, I've used targets, I've used suspects. They may mean the same thing or different things. Now, for ethical hacking, the individual or the system you're trying to access is the target system. But in forensics, that system you're trying to access becomes the suspects. Okay, so that's why you see me use them interchangeably, because we are working with attacking systems and also for forensics. So for reconnaissance, one of the major tools that we use in industry is the Nmap. Okay, so your Nmap should be already installed for you. So we're going to perform scanning. We're going to scan the network, and then we'll see that what comes out. Now, before we go into the lab, I have a script where I have documented all the commands that we're going to run in this lab. So the slides may not have all the commands, but the script has the commands. We just copy the scripts, copy the commands, and then dump them on the Kali and see the output. Then we can explain further. So when we run this command, we see the result, we'll come back to the slides. So let's go to the script. So for the lab we're working with, the first thing we expect you to do on your machine is to perform updates of packages by running this command. So you can just drop this command, and this might take you, depending on the last time you did update, this might take you say 5 minutes or even more. And then the other command you need to also run is for it to do upgrade. So After this one, we just do upgrade. So let me put it here, sudo apt upgrade, and then add a flag y. The flag y is to say yes whenever it's asking you to say yes or no to Momo. So then the next other thing is for you to install Docker. On my machine, I've installed Docker. So that is what we have on the, I'm talking about number 2. So, and then that is, you have to install the Docker, and that's a command. Just copy this sudo apt install -y docker.io. So this is all for you. And then step 3 is to start the Docker. Okay, you can start and enable Docker to run for you. So you can just copy that and download this on my machine. And then the fourth one is to see if Docker is running. So let's see whether Docker is running on my machine. So I'm just going to copy this command. And then I go to Kali. Let me just log into my Kali. And then launch terminal. I prefer to run terminal as root user. Yes, so I'm just going to paste the command, right click, and then paste clipboard. Looks like that didn't copy. Seems I didn't copy that, so let me go back and then repeat the copy. Minimize this. Yeah, let me try this again. Copy, and then go to the machine. Right click, paste clipboard. Okay, so it's fine now. So I'm going to just status. So you can see here active running. So it means Docker is already running on my machine. If Kali were not running on my machine, it would have shown something. It would have shown inactive, meaning that Kali is not running. So in this case, Docker is already running on my machine. So let's go back to the script and see the next thing we need to do. So step 5 is we will have to now install the Docker Compose. So we can just copy this again on 5, copy, and then go to the machine, go to Kali machine. Okay, to step back out of this, can you Control-C? That takes you back to where you were before. So just right click and paste clipboard. That's okay. So it's installed. So I can say that installation is really quick. So you can confirm that your Docker is working fine by running what you have on step 6. First, you can check the version of the Docker you want, and then the next thing is you can check the version of Docker Compose. So again, you can just do that. Just copy and check if this is going to give you the version of Docker. If Docker is installed and it's running, it's going to show you the version. And then the next one, Docker Compose, is going to show you the version as well. Just copy this from Docker to Docker version, and then drop it, or you just run this one, Docker Compose. It's going to give the file version. Okay, so the next is essential command for us to do. All of these commands are important for us to do. You can also, I've added something here. There are times that your Docker might fail. So in that case, just run this command. That is, if you check the version is not showing, and then run sudo cmtl and then systemctl and then Docker. It's going to check the errors for you, and then this is going to solve whatever problem that you have for you. So in the step 7, you're supposed to run the lab after the Docker is installed. So you would have installed Docker. You've made sure Docker is running. You've checked the version of Docker. Docker is fine. Docker Compose is also fine. So things become interesting. So in step 7, you are supposed to, at this point, you're going to have to clone the lab from the repository. The link is here, listed here. So just copy this link to Kali and then dump it and then run it. It's gonna clone this repository for you to pull the file from whatever the files may have been. But then you have to make sure that your device, your VM is on the internet. So you can set your network adapter to NAT or to bridge so they can access internet before you clone. So for my system, I've done the cloning already, so I don't have to run this command. So what for me to start working, I need to now change directory. CD is changing directory to this. So after cloning, it's going to create this directory for you and then dump the files for you. So we're going to change directory to files. So I go to my machine. All right, so I'm going to do ls. ls is to list what I have in my root directory. So it shows that I have that directory, this secure server fortress. So I do cd secure. Okay, it's already here for me. Just enter. Okay, so that takes me into the directory. I can do ls to see the files I have. So I have some files. Yes, on some subdirectories in that directory. So that's what you do for me in that step. So the next thing is to grant permission or change permission to this file or these two files. Set up the sh and clean up. These are batch files. They're going to help us to do some things as we proceed. So we have to change directory by running the entire command. Just copy this. Or you might decide to break them down. You might decide to say, okay, I'm going to run them separately. It's your choice. They're all the same thing. That's to say I can run it this way. So that's run them separately if you want. They do the same thing. Just going to help you solve the problem. Okay, so I'm going to copy the two of them at once and then run as C. So right click, paste clipboard. So I've changed the directory of the two files immediately. So it's as simple as that. So like I said, you can run them one by one if you choose to do so. Now it is possible that while you're trying to change that directory, oh sorry, the next thing is to install. Okay, I forgot that. So just copy this and then install. Also, that's to run, not install rather, to run. So let's run this. I think space. Okay, let's just do it manually. Set up, right? Set up. Okay, so let's see. It's going to run the script right now. So it's running the bash script. You can see the containers now. Elastic, Stash, Kibane, Secure Bank, Logstash, Kali, Attacker. So let's see. All right. So let's say this will be done in the next few. Okay, it told us 30 seconds, so it should be less than that. Good, we are done. So it has told us to do some things here, but let's follow the script so that we're easier for us to understand. So while running this script, it's possible you have an error, like they're saying DPK error, processor archive, and the rest. You may have this error. So if you have this error, these are the things you need to do. Okay, I don't have this error, so I don't have to run all of this. But should you face that error, so you have to run the steps from I to VII. It to clear out the error for you. So then you can move on to step 8. So in step 8, I said, if everything works, then you can have to set up the script to run. So we've done this already. Yes, this is what we did here. here. Yes, we did this. So we've done this two already because we don't have this error. So we don't need that. So we'll go straight to step 9, where you have to now start all the containers by running the command sudo docker compose upd. So what we do is going to now run the start the containers, the 6 containers. So let's go to Kali, right click and paste clipboard. So you can see that the 6 containers, okay, it has shown us actually that there are 6 containers, 1, 2, 3, 4, 5, 6, and the 6/6, and all of them are running. You need these containers to run before you proceed with the lab. All right, so then in step 10, the goal is for you to verify whether or not the 6 containers are running. So what you do is to run this command, docker compose ps, to show you the processes that are running. But in our case, they are fine, so we don't need to check that. So we can move to step 11. In step 11, we want to enter the attacker container by running this command. So the command is this. Just copy this command, then we go to Kali, right click, paste clipboard, and then run. So it's done. It's just that. So and then step 12 is we are going to do our scanning now. Now let me switch to the slides now. So I'll show you. That's where we left off. Yes, this command nmap svp 80 for 335,000 to 80, and then that's a command for scanning, using nmap to scan the network or to scan the application. So when you have secure bank IPP, that is the application. So you might want to change that to an IP address of the application where it's running. It's fine in case this doesn't resolve. So let's go back to the scripts. So we're just going to copy this, and then go to Kali. So it's scanning on port 80, scanning port 80, 88, or 8080, and then which other port 5080, yes, 443. So the result is that you can, of course, we've seen a table, port, state, service, and version. Port 80 is running the service called TCP, and the state is that the port is closed. Okay, and the service is HTTP. 443 TCP is also closed on the service is HTTPS, and then 5000 TCP is open. So, and this is actually what we're looking for. This service, which is a pattern, that is our Flask. The app.py file that we talked about, the intentional vulnerable application, is running on port 5000. So it means that we can do some things around this. Now, port scanning, in ethical hacking or in hacking, as it were, you need to find out what services an application is running, what version, what database, what operating system, what port is opened, or the state of the port. So the port can be closed, can be open, can be filtered, and many more. So, but you need an open port for it to gain access to the application to do the things you need to do. So in our own case, the service is on port 5000 app. The HTTP service is open for us to exploit, and it has also shown us the port and the MAC address of that. So that is what we expected to get from that. Now, looking at the slides again. Now, the expected findings of this experiment we just did now, the lab we just ran now. We expected port 5000. Of course, we saw it. We also saw the service, which is a pattern Flask application running HTTP, and then the version information was also shown. So that solves that for us. So let's continue with the slide. So the other thing you need to know is service enumeration. We have port 8080 where our banking application runs, our vulnerable banking application runs. We have port 5601, which is a Kibane dashboard. We have port 9200 for our Elastic REST API, and then port 5000 for our Logstash inputs. So there are vulnerable endpoints we're supposed to that are actually in our script. So in our file, which is app.py, we have the login get, we have the login notification endpoints post, we have the account where we do the account view using get. That is with the command injection, you can exploit that. And then for search, which has the search functionality using the get, cluster scripting vulnerability is available there, so you can exploit that. Then we have the transfer endpoints. For fund transfer, we have the logs endpoints for viewing logs. All of these endpoints are vulnerable, that can be exploited. So, yeah, for printing the application, we need to know the technology stack that an application uses. So, as an ethical hacker, one of the things you will need to do or learn is know about an application is to know the technology stack. So in this case, application is using the pattern Flask. Flask is a framework for Python, and then we have MySQL for our database, and then the debug mode has to be enabled. So in this case, line 93 of our program, the debug mode is set to true, and then there's also hard-coded secret key, which is on line 10. And then the directory structure is putting some error messages that can be exploited. Okay, so those are the things we gather doing for printing. Okay, so let's go back to the scripts. All right, so we have completed step 12, where we perform scanning. Scanning the container. So in step 13, we are expected to run data scripts. That is initial exploitation. So we have to directory to the scripts directory, move down here. So we have to run this. Then we'll run this command. This other command is to enable permission, and then we'll run the script. So let's begin with let's copy this. We change actually to scripts. So I'm going to do cd scripts. So let's see what's inside. ls list. So we have two files. We have the attack scripts, which is a bash file. We have the forensics. So let me paste what I copied. Change permission, that is successful. Then the next thing is to run. So let's run the command now. Dot / then the bash file attack .sh. Let's run the scripts. So we are launching the launching our attack now by calling the attack script. So let's wait to see what this happens or what this does. Okay, so it's completed. So it has been able to exploit the application, and then of course we're going to see the application it looks like. And now for us to confirm that it's working. Now one of the things we're going to see in the application is that there is a link. There's an upper link called view accounts. And when you click on this view account, it's going to take you to this link or this file. Okay, and the other things will follow. And then the other thing we're going to see is that there is a line called welcome admin or 101 equals 1. So it means that the application has been exploited by that script. That script is a payload that has the ability to break into the application that we're trying to test. And then the test we've done is SQL injection, you can see here. SQL injection. So let's go back to the scripts that we have. So what we've done now is we've completed step 13. We changed directory into this directory called scripts. We enabled permission, and then we launched the attack script. So in step 14, we're going to verify that the web app is accessible. What we do is to just open a browser and then access this address, localhost 8080. So we're going to see if we can access the web application. So then again, we go to Kali, and then let's fire up a browser. The only browser we have here by default is Firefox. So let's give it some time. All right, so it's ready now. So localhost, what did I do? Localhost port 8080. So let's see. Wow, that is the web application that we have. All right. Now I was telling you about what was I even saying? Okay, that we can actually exploit what we did. The command that we ran was able to exploit using SQL injection. So we can access the document using the valid login is admin, username admin, 123 is the password. We can also use this command, this payload, to launch SQL injection. So let's log in normally. Admin 123. Right. So it says welcome, and then we can view account. What we saw on after running the command that we did, we saw view account. So that is what we are saying here, view accounts. Okay, so it means that you log in. If you log in normally as a user, you can have access to the account. You can also exploit that. So we can view account to see what is in the account. There's a table, yes, of the application, which a normal user can log in, but we are trying to break into this application without logging in as a normal user. So that's it. So what you've completed steps 1 to 14 right now. So the next step is for us to perform manual exploitation, SQL injection. Okay, we ran a script, the attack script, and then we're able to also log in as a normal user. The next is for us to perform manual exploitation, and that is what we saw on the slide, which is on the initial exploitation. Okay, so for SQL injection demonstration, this code, that is app.py, ts.py, lines 28 to 29 reveals lines of code that can be exploited. As you see here, query equals f-select, or from users where username equals, put the username, and password equals password. So with SQL injection, we don't need to know the username, we don't need to know the password. So an attacker doesn't need to know the valid credentials. Just launch the attack and see if that can be broken into. So the payload we're going to use is this. Username we're going to use is admin. We're going to in place, and that username box, we're going to put, that field, we're going to put admin or 1 equals 1, as you see here. Password, we'll put anything, just type anything there. And then the result of the query is that when it hits the database, it will be translated as select all from users, where username equals admin or 1 equals 1, and password anything. Okay, and then that is going to exploit the system for us. So let's see how that works. So let's copy the command from the script. Let's copy. Let's just copy this for username. We go to Kali, we go to the terminal, and then from the interface. So let's log out first. So here, put what you just copied, and then anything, just type anything there. And then let's log in. You can see that it has taken us into the application. The same thing. So what it means is that an attacker can run just that simple payload and then gain access to the application as an administrator. So whatever an administrator can do an application, a hacker can also do that, can break into it and then make changes to whatever is there in the database. So that is what you've done in step 15. Then in step 16, things get exciting. Now you're moving from exploitation now to collecting evidence, forensic evidence now, so that we can perform analysis of that. So before we come back to the script here, let's go back to the slide. Let's see what the slides are saying. Let's see. Okay. Before we move into evidence, the forensic evidence, the impact of what you've just done, the script you ran, the attack script that we ran, or the command, the payload that we launched, the impacts are that one, we're able to bypass authentication. So without an attacker knowing the username and password, the attacker is able to bypass the login interface, and then the attacker is also able to have access to that main account. Like I said, you are able to enter the dashboard as an administrator. And then once you're able to access the admin account, of course, you can steal data or modify data. So there can be cases of data mutilation or data exfiltration where you can actually steal data. That is important. So that's it. So the next thing we're going to do is to perform command injection. The one we did before is SQL injection. So the next one is command injection. Now, the script again, looking at lines 48 to 52, it has these 3 lines of code, 3 or 2 lines of code, account, ID, cost request, and all of that. So the vulnerable part of the lines is this last line that says result equal os dot p open cmd read. So that's it. So and now these are the payloads. We have the first payload. Sorry, let me get the pen. Let's get the pen. Okay, okay, so this is the first payload we're going to run. Just copy that entire line of code and dump on the browser and see what will happen. And then the second one is this other payload. Just copy and dump and see what happens. So and again, I've added this on the script. Let's see this on the script. Okay, so okay, it's not on the script, so let's just copy from here. Let's copy from here. Let's copy this. And then go to the browser on the Kali. Just open a new tab and then dump this here. That didn't place. So we can see that takes us straight in. Okay, this doesn't require to run a command or to log in normally. Just that on the URL, just dump it, and then boom, you are in the application. As simple as that. That is command injection. And then the second payload for command injection is also there, so we can try that out again. And let's copy that from here. Just copy this. Copy this, and then go to Kali again, and then look for terminal now, browser rather, a new tab, and then dump this. The same thing. So you can see that you're able to bypass authentication, and then we are in the application. So let's see what else we have on the slides. So okay, the next payload was expected, or the next attacking type is supposed to perform is cross-site scripting. Okay, that's SS testing. So, and then again, the lines that can be exploited on the application are line 64 to 66. And the scripts or the lines are written there, query equals request dot arguments get and the rest. So the payload is given here. This is the payload. Oh, sorry. I tried to mark that. Let me get pen again. All right, this is a payload. So we're just going to copy this and then dump that on the browser again. And then what this is going to do is going to run a script, this script you see here, and then to bypass authentication and then get us to the application. So let's copy this. Let's copy this. So go to the Kali again, open a new tab and dump this. So it's successful. So search for results back. And then, so you can see that our attacker is able to launch attacks if the application is vulnerable. And these are the different types of attacks that can be tested, as we have seen. So that is for initial exploitation. So the next thing we have is collecting digital evidence now and then mapping the evidence to the discovery. So from what we've done now, we've done attacking. Okay, so now, so the next phase is for us to collect evidence, and then we have some files we're going to be created for us. Of course, as we have launched attack, we can actually collect evidence of what we've done into log, which we're going to analyze later. So in the script called attack.csh, we have lines 41 to 45. What they do is to create some files for us. So we have attack, echo attack executed at the dates, and that can be stored in the evidence/attack timeline text. Then we have the echo attack with IP address. We have the echo target secure bank application. Then we have echo techniques used. Showing you the kind of payloads or attack patterns that have been launched. That is the attack timeline creation. And then we need to also know the log file locations and what formats they are stored. So I'm going to show you the directory called evidence directory, and then you're going to see some files. So one of the files we're going to see is the attack timeline.txt. What it does is to store the manual timeline of the execution of attacks we've done. And then there's a secure bank.log, which contains application logs. We have a network connections.txt, which stores the next start output. Then we have the runners processes.txt, which has the processing outputs. And then we have the hashes.txt, which contains the file integrity hashes. I'm going to show you these files shortly. When we look at the log formats in the app.py file, between lines 12 and 16, it's written a login.basic config and the rest of them. So it's going to, those lines actually create a log file or create contents to store in the log file for one to review. And then one essential thing we need to know as we learn along the course is what we call evidence collection methodology. So we have the process for automated collection. Of course, we have manual collection of evidence. We have automated collection of evidence. Once you run the forensics.ch script, so it's going to collect the evidence automatically for you. So you don't have to do manual collection of evidence. I've talked about manual collection, which allows you to do direct examination of logs. Then we have the tool-based processes like the nmap scope that we did, or the core request we're going to be running as we move on in this course. Then we also have the time synchronization, where all containers are expected to use the host time, and we can take care of that as we proceed. There is what we call chain of custody in digital forensics examination. The chain of custody is able to provide the guide or the steps on how you collect evidence, how you handle the evidence, how you analyze the data, you extract data, you analyze, how you report the data, and how you preserve the evidence and the report or the data. So all of the things you do from the point of acquiring evidence to examine the evidence, reporting all of those things, they come under the chain of custody. So for the chain of custody documentation, you need to state in that documentation the evidence created. So in our case, we have everything done in container. So we need to know the container volumes. We need to do copy to host. Of course, I'm going to show you the directory, the evidence directory, where evidence collected is stored in that directory. The hashes have been calculated using MD5 sum, and then we have the timestamps recorded from the system logs. We're going to see that the documentation of collection processes, all of these are the chain of custody in this lab. But in real lab applications, the steps involved in everything you do from collecting your evidence to completing your work will form the chain of custody. The key evidence file we're going to be seeing shortly one, the securebank.log. What it does is to store the application security events that happen. We're going to see that. We have the attack timeline, which I talked about briefly a while ago. What it does is to document the manual attack strategies, or successful attacks or failed attack attempts. We have hashes.txt. What it does is to hold integrity verification hashes for you. And then we have network and process snapshots. So before we go into finance, let's see what you have on the scripts. So in step 16, we are supposed to run we are supposed to collect forensic evidence. So I've added here that while you are still in this Kali container, you change directory. I think we're already in this subdirectory script, and then we can do apt get updates. You don't have to do this before because we've done this before. So we'll leave all of these ones and just go to changing the permission for this file, the forensics file. Like I said, this forensics file, what it has to do is to collect evidence for you automatically, and then we'll run it. So we'll change permission and then we'll run that file. So let's see. Let's copy this and go to Kali. Let's log in again. So go to terminal, and then we are still in the script directory here. So right click, paste clipboard. Nothing's pasted. It means nothing was copied. Let's try the copy again. Repeat that process. Right click, paste clipboard. Yes. Yes. So the next is to run forensics .sh. Command not found. Which command is not found? It says cannot find this command forensics. Okay, let's see. Let's go back to the scripts. Okay, let's run this. Let's see. So when it try to run the forensics.sh command, it will likely tell you that the command is not found. So if you have command not found, so what you need to do is to simply install app2 or ProCPS. So if you go to the script that I prepared, let's see the scripts. yeah, this line, you need to install it. You need to run this command so that you can flow with this, with the running of the forensics.csh. So with that in place, since that is successful for us, so the next is to run step 17. Just copy this. That is to check the evidence that we collected using the file we just run. So let's go ahead and dump that on Kali. So right click. That click is not working here. Right click and then paste clipboard. Just run it. So now it has shown us what we have in that directory called evidence. We have attack timeline that I talked about a while ago. We have disk usage. We have hashes, log files. We have a lost directory. We have network connections, network interfaces, running processes, secure bank. Now these are all files that contain the evidence that have been collected from the attack with the exploitation that we did. So we're going to explore some of the files as we move on. Okay, so let's go back to the script and see the next thing that we, yes, the script before the slides. Let's see the next thing that we have to do. So that's actually the last command we need to do. So let's look at the slides to see what else we have to do there. So now looking at the findings of what we have done so far, let's see. Now looking at the vulnerabilities identified, we'll be able to launch a SQL injection, which is a critical aspect of attacking an application or a web application. So, and the major endpoint that was exploited is the /login endpoint. And then the impact, and like I said before, we're able to bypass authentication and we're able to do data extraction. That is, you could steal data, mess up the database also. And the code reference for the scripts, we'll have that in lines 28 to 35. And then we did command injection, which is also critical. And that command injection targeted the account endpoints. And then the impact of that is remote key distribution. Of course, one can do that. And then the code reference, lines 48 to 52. Moving forward to number 3, we have cross-site scripting, XSS, which is high. And location, that very payload or the attack pattern target the search endpoints. And the impact a client-side code distribution, which is possible. And the lines of code are also shown. And then we have the debug mode enabled. And that's target application configuration with the impact of information disclosure on the 3. So number 4, we have hard-coded secrets that has medium severity. And the location is similar to the previous one, but this time around, the impact is session hijacking, as you can see on line 10 of the program. So looking at the evidence collected, we have seen more than 5 log files with attack patterns. Okay, now let's see if the files we've collected are up to 5 or above. Let's look at this again. You'll see attack timeline 1. So we have 1. We have 1, and then we have 2. Sorry. Okay. Then we have this is 2. We have hashes 3. Log files 4. You have network connections 5. Network interfaces 6. Running processes 7. Secure bank 8, and then the SUID binaries. That's nice. So we have 9 block files that have been collected by the scripts that we run. So that's it. So we have more than 5 log files collected. We've not done screenshots of successful exploit, so that's not a problem. And then network scan results, we did Nmap scan and all of that. Then looking at security gaps discovered, input validation. So the fact that we're able to launch SQL injection from the user interface, we don't know the username, we don't know the password. It means that the forms were not validated. Then output encoding, user directly reflected responses, as we're seeing because of scripting, and then we have query parameterization. It means strong concatenation in SQL queries were not handled properly. So the test we've done also shows that command citation was not cut that. For instance, there was unsafe use of os.pupil method. Then error handling wasn't properly taken care of. For instance, it told error messages could be exposed, and then security headers will have missing security. Then initial recommendation, because the goal of a pen testing or ethical hacking is for the pen tester to suggest or recommend to the IT team what can be fixed or what should be fixed, and also recommend to the management, because like I said earlier, that when you're putting up the reports, your pen testing reports or your ethical hacking reports or the forensics reports will be consumed by the IT team and also by the management team. So we are going to make recommendations. So, and of course, the recommendations are going to be, some of them are going to be immediate, some are going to be short term, and some are going to be long term. What they have to be fixed. For instance, for immediate recommendation, you have the production team, that's the software development team, while building the application, will have to disable debug mode in production. So while moving the software from the development environment to the production environment, that has to be disabled. And then they also have to implement input validation for all endpoints to make it hard or difficult for SQL injection to be carried out. Then they also have to use parameterized SQL queries. That also helps to fight against SQL injection. And then for short term, now those ones I've mentioned, those three are actually for immediate. For short term, implement output encoding for reflected content, replace os.pupil method with secure alternatives, and then we did hard-coded secret keys. As a matter of fact, we actually recommend that if you're going to have to, if your program is going to have secret codes, of course, go to your .env file to add that instead of putting on the script, instead of putting on the code. Number 3, monitoring. Review what you have in your Elasticsearch logs for attack patterns. We're going to see that. We're going to see how to do that in the next lab, and then set up alerts for suspicious login attempts. Next lab, also going to see how that works, and then monitor for command injection patterns. Also next lab. Thank you for this lab. Then if stay with me, please join me in the next lab as we move into something more technical and deep. Thank you.